Hello everyone. Today I will talk about how we can use biosignals for recognizing stress levels, and how can we alleviate the high stress levels by using wearables and immersive technologies. I am Yekta Sayıtcan. After a brief CV and definition of stress, I will talk about different components of a stress recognition and alleviation system. So after graduating from a computer engineering department in Boğaziçi University, Turkey, I actually continued my MSc and PhD in the same university. And during my PhD, actually, I was involved in an EU ITM project, Affectech, and I developed a stress detection system in real life. And actually, I use physiological signals and user feedbacks along with some advanced machine learning algorithms. After my PhD, actually, I worked as a postdoctoral researcher in a prestigious EU ERC project for 2 years. Then I moved to Germany. Then for 2 years, I am working as a postdoctoral researcher in University of Augsburg here. So let's define what is stress. So stress can be non-formally defined as the body's way of reacting to any demanding or hazardous situation. So when stressor comes, we check our resources. And if we feel that our resources are enough, we go back to the baseline state. But if we feel that our resources are not enough, we enter into mental stress. So this can be explained in an algorithmic manner this way. When we look at stress, actually it is in the high arousal and negative valence part in the 2D emotional space. So there are two types of stress. So acute and chronic stress. Acute stress typically results from immediate demands like a deadline or dangerous situation, and is usually actually resolved very quickly. But in contrast, chronic stress is ongoing. It can actually result from a persistent work stress or relationship difficulties, and can lead to actually long-term health issues. So acute stress actually can be beneficial and helpful, in these emergencies or some deadlines or some dangerous situations. But chronic stress actually can lead to prominent conditions. It has actually negative impact on body systems. For example, it increases heart rate and blood pressure. If it is consistent, as in chronic stress, it can strain the heart and blood vessels and increasing the risk of heart disease. It has also negative impacts on immune system. It suppresses immune function and making the body more open to infections and slowing the healing process. It also actually increases cortisol levels, and if it is consistent, it can disrupt metabolism and other bodily functions. It has also negative cognitive and emotional effects. For example, it affects the brain, especially memory and learning parts. And chronic stress can shrink the hippocampus and actually impact memory and spatial navigation. It actually also causes anxiety and depression, and it impairs the ability to actually regulate emotions and actually leading to mood swings. When we look at actually, it has also negative effects on productivity, burnout, and job satisfaction. Especially, you can see percentage of adults who feel overwhelmed by stress most days, and especially under 45, you can see that actually 50% suffers from this overwhelming stress. So as you see, actually stress is very harmful, and what can we do with our biosignals? We have highly competitive work situations, heavy workload, time pressure, financial issues, relationship difficulties. So first, by using physiological signals, we will sense our physiological signals. Then we will actually come up with some automatic stress recognition that can recognize high stress levels. When it recognizes high stress levels, after that, we need to offer some stress management techniques so that we will alleviate the stress levels, then we will return people to their baselines. So why biosignals for this stress recognition? There are also another ways. For example, we can ask users frequently how they feel. But generally, people are reluctant to give these answers frequently, and these actually answers are generally subjective. So it has actually they cause some issues there. We can also use facial expressions or voice, but actually these methods are generally considered as, it raises some privacy issues. So biosignals actually have less privacy issues, and they are objective, and they are more unobtrusive. We can use them in our daily lives. So the first signal is actually heart rate variability. So heart rate variability is a variation in time between R peaks of, for example, ECG signals. So it is the most prominent signal in daily life for discriminating stress because actually this autonomic nervous system influences heart activity directly. So as you can see here, sinusoidal form of heart activity is disrupted under stressed situation, and our heart rate variability is also decreased. Another signal we can use is actually electrodermal activity. It is the change of electrical properties of skin. So under emotional arousal and stress, body sweats and skin conductance increases. As you can see, after some stimulus with some latency, skin conductance increases due to increased liquid, and after some recovery time, it goes back to normal. So this is the change of EDA signal after a stressor. Brain activity is also important. Billions of nerve cells actually create small electrical signals which forms brain waves. So EEG amplifies and records these signals, and rapid beta wave frequencies are considered as a characteristic indicator of stress. So here you can see actually beta wave frequencies under stress and under relaxed conditions. Individuals also demonstrate behavior and gesture changes when feeling stress. So they include jaw clenching, arm movements, self-touching and finger rubbing. With some accelerometer sensor, we can detect these changes and try to actually recognize their stress levels. So if we want to actually detect stress in daily life, we need to choose unobtrusive devices. You can see above devices have some cables, boards. Although they have higher data quality, we need to go with this below devices because they are more suitable for using in daily lives. However, these devices have lower data quality. Here you can see ECG signal structure obtained from a medical grade device and a PPG signal, which is a proxy for ECG, which is actually coming from the heart activity, but you can see that ECG has more information and actually a better structure than PPG. Also, in daily life, we have unlimited movements. So these unlimited movements can cause some data gaps in our devices, and actually it can create artifact data points which are actually noise. So we need to come up with actually robust processing algorithms to overcome these issues. Also in daily life, we rely only on self-reports for ground truth. So, but these ground truth has some issues such as people can be unaware of inner self. They don't give importance to the experiment, for example, or they try to hide their real emotions. For battery life, actually battery life of wearables is not enough for continuous daily life monitoring in the current state of the art. People have to charge their devices every day or in every 2 days, which causes reluctance to use these devices after some time. If we use actually multiple biosignals, we can get actually more robust systems. But using multiple biosignals sometimes requires using multiple devices, which can be problematic due to connection and synchronization issues. But in our chair, SSJ framework, which is an open source framework for signal processing on Android devices, is developed. Actually, it enables recording, processing, and classification of multiple sensor data in real time. So you can actually use a lot of sensors, and actually you can record the data, transform the data, extract some features, and actually you can then save the data in some files. So it actually enables data collection with multiple devices easily. Okay, so after we collected these biosignals, we need to come up with some automatic actually stress recognition system. So this system should not need extra obtrusive equipment. It should have a generic implementation. It should work with commercial smartwatches and smart bands. We need to come up with some modality-specific artifact detection due to the above mentioned issues. And we need to extract the most distinctive features, and we need to apply a wide range of classification algorithms. So after we develop such a system, we need to actually test this in different experimental settings. So the first setting is in the laboratory. So in the laboratory, we know the context at any time. We have more reliable ground truth. Movements of the subjects are is limited. And in 1 hour laboratory experiment with, for example, 14 university students, we were able to recognize stress levels successfully in the laboratory environment. As you can see, we have around 95% accuracy for 2-class stress detection result. After detecting stress in the laboratory environment successfully, we took a step into the real life. So in real life environments, the stress detection performance is always lower than laboratory because these environments are ambulatory and movements are not limited as laboratory environment. But thankfully, participants follow a pre-arranged schedule of the event so that we can get some context information. So we tested our system in these environments. Although the performance is relatively lower, we have achieved acceptable results for real-life scenarios, as you can see, around maybe 85%. But in the daily life, in daily life environments, stress detection performance is the lowest when compared to the previous environments. So we don't know the context of individuals, we could not observe them with cameras or other devices, and the movement is totally unrestricted. So when we provided smart bands to the people and when we monitored their physiological signals for a week, actually 2-class stress detection accuracies are around 70%, which is actually far away from a robust performance. So we came up with some techniques to improve our performance. For example, what if we develop our models with the data collected in the laboratory environment and test our performance in the daily life, instead of developing and testing our models in daily life. Because laboratory data is actually less noisy, so we can create better models by using this way. And actually we have achieved around 20% accuracy improvement by using this technique. Another technique is actually high-level error correction. Here you can see our system's decisions for 1-minute windows. But actually physiologically you cannot go from stress to relax and go from relax to stress in only 1 minute. So clearly this is our system's mistake. So by looking at this high level, we can correct our system's mistakes and we can get actually better accuracies. Adding contextual information is also very important in daily life. So we try to add physical activity intensity, activity type, location, calendar information, and even weather information to improve our system's performance. Actually, lately we also explored RNN variants because actually they are more suitable to time series data, and we tested actually different variants of this RNNs, and actually we again have some improvements. We also developed actually mood-aware emotion recognition system. So emotions usually have a stimulus event, are relatively intense and short in duration. On the other hand, moods consist of actually long-term sensations that are more stable than emotions. So a famous actually psychologist, James Gross, resembles emotions to fluctuating changes in weather, whereas moods resemble to persistent emotional climates. So moods can be employed to accurately differentiate the negative and positive valence of emotions. For example, when you are actually in a negative mood, you are more likely to have negative emotions, whereas when you are in the positive mood, you are more likely to have positive emotions. So we can use this relation between mood and emotions to enhance our performance of automated emotion or stress recognition systems. Here we automatically predicted mood information from biosignals. Then we added this mood information to our classification system for emotion or stress. So again, actually, we have some improvements, in our model. Since we are dealing with actually human biosignals, privacy is also important here. In a traditional way, generally data is collected in the local devices, then this data is transferred to the servers. Actually, but during this transfer, actually the privacy of the data is not preserved. So, for example, there are some techniques to improve privacy. Federated learning is one of them. Instead of actually uploading the data, we can develop some local deep learning models in the device. Then we can upload the parameters of these models to the server instead of the data directly. So we can actually have some improvements. And there are also other techniques called, for example, differential privacy, and we can add some noise to improve our privacy even more. So when we actually apply these techniques, for example, federated learning, we improve the privacy without a sacrifice in the performance. So this is actually a very good result here. Okay, so after we detected stress, we cannot say people, okay, you are stressed. So we need to actually manage the stress. How can we manage stress? So according to James Gross's emotional regulation theory, so we have some situation, we select some situation. Let's say we have an incoming presentation. So we deploy our attention to this situation, then we change our cognition, then actually we create some response accordingly. But if we can modify this situation, for example, by adding some relaxation method, and we can change the attention also, then we can change the cognition accordingly, and actually we can create a response accordingly. So this is what actually exactly we did. We tested this actually theory in a real life event. There was an EU project training event, and in this event PhD students will present their midterm progress in front of the referees. And we added some stress management methods such as mindfulness, yoga and meditation during this stressful event, 9-day event. So when we look at actually this self-reports and biosignals, we can actually clearly distinguish this stress management sessions and the other sessions. So we can see their success in both self-reports and biosignals. So another technique can be forest walking. So spending time in nature is actually known to reduce stress and anxiety and improve mood and cognitive function. So these effects of natural environments are centered on the Shinrin-yoku, which is actually a Japanese principle, or forest bathing in English practice. So we combine this forest bathing and walking, which is a physical activity, to maximize its effect. Actually, we conducted some forest walking experiment in Augsburg forest. And to compare, participants also walk in the city. So as you can see, in doing forest walking, the perceived stress decreases, whereas in city walking, unfortunately, it doesn't decrease. So from self-reports, we see the effect of forest walking on perceived stress. When we look at the biosignals, the stress level can be differentiated after city and forest walking. Here you can see the beta waves in the brain activity. So you can see after city walking, the stress is higher than actually after forest walking. So we were able to see the effects of forest walking by using biosignals also. So combining immersive and wearable technologies is also important. Generally, VR system evaluations rely on perception-based measures like questionnaires. But if we can add physiological signals as a measure, we can have a more objective response. So in this study, we actually, in a VR environment, participants were solving some 4D puzzles. And actually, we defined 3 difficulty levels: easy, medium, and hard. And user can also tag aha moments here, where they solve the puzzle. So by using HRV data from wearable sensors, actually we were able to differentiate different cognitive load levels successfully. And we made another experiment by using immersive technologies, and we tried to recognize flow state during music collaboration. So musical collaboration actually improves self-esteem, mood, and cognitive abilities. And flow state is actually joyful state of complete absorption in the music making. So it has positive balance and high attention during the performance, and actually it has positive correlation with well-being. So by using biosignals under this immersive, mixed reality condition, we try to detect flow states. So as you can see here, this is audio only condition, and whereas in the audio and mixed reality, where when the music collaboration happens, actually they can see the partners actually mixed reality image by themselves. So actually we can distinguish flow states more easily when we use also mixed reality, which actually shows the importance of using these immersive technologies. So we should use actually a combination of immersive and wearable technologies for stress management, because modern lifestyles require health and practical interventions that can be applied indoor environments. So in this point, actually applying VR and AR technologies can step in and enrich our intervention pool even further. For example, I showed you that forest walking reduces stress levels. But it is not always possible for modern day people to leave the work, walk in the forest and come back. So instead, by using a treadmill and a VR glass, we can simulate forest walking indoors. So this allows us to actually apply many outdoor techniques practically in indoor environments, such as guided imagery, breathing techniques, or meditation. So after we suggested some stress management techniques, determination of a good recovery is also important. So an ideal system should monitor biosignals objectively to objectively analyze whether the method is working or not, whether this our stress management technique decreasing the stress or not. So because in time it might start not working due to change situations or context. So in these cases, the system should suggest the next best alternative to the users so that we can find a working solution. We can use reinforcement learning by using an award system in these cases. So to conclude, an unobtrusive response device-based device stress recognition system was developed and tested in different environments, in laboratory, in real-life environments, and in daily life environments. So we actually proposed several techniques to improve relatively low performance in the wild. And immersive technologies can be used for stress management in indoor environments and enrich our pool for intervention techniques. And we should also deal with privacy concerns by employing federated learning and differential price techniques. And we should close the loop by monitoring the recovery, whether it is a good recovery or not, by using biofeedback, of course, objective biofeedbacks. And we should actually suggest the next best management system to the user. So thank you for listening. Any questions?
Extensive talk, and I can probably moderate the questions. If you want, you can ask in German. I can try to, or probably you can also try to answer.
Translation is better. Yeah.
Okay, so are there any questions? Okay, let me start with the first question. I think you talked a lot about stress and also using, for example, VR glasses or indoor environment, but it's also in a way that for healthy people, I think it's good to have VR glasses. But if you think about old people, let's say, for them it's probably already too much stress, let's say, to wear such a glass and also walking on an environment. Right? What would be another possibility for old people?
Yeah, actually, I showed, I applied actually this traditional stress management techniques, walking in the forest, meditation, mindfulness, yoga. So they are working. But actually, I think it is best to, if you have the chance, I think it is best to apply them. But actually, if you don't have the chance, VR can be alternative for you. For example, you are in some office, so and you are stressed. Maybe you have some interview or some presentation or some deadlines, etc. But you have only maybe 10 minutes. Maybe there could be some relaxation room that you can go. In 10 minutes you can simulate some forest walking. By just taking this VR glass. But of course, original is also working, and we also see this in the biosignals and self-reports. But this is just an alternative. But if you can apply the original one, I think you can also do this. Yeah.
So kurze Zusammenfassung war meine Frage, wie könnte das dann funktionieren für ältere Leute? Und was Dr. Hector meinte, könnte natürlich auch für ältere Leute funktionieren, aber muss das auch in diesem begrenzten, zum Beispiel im Büro, kann man das auch in einen Raum machen, wo man die Leute dann hingehen und vielleicht dann auch die Stress unterzudrücken, kann man da die Sachen dann, was er vorgestellt hat, kann man machen. Gibt es noch Fragen?
If the people are already in a stressful situation and then there's like the signal from, let's say, an app or whatever it is that's serving them, wouldn't that rather increase the stress they have? Because it's like, I'm already stressing out, there's something putting me under pressure, and then there's, I'm being surveyed by something. So wouldn't that be rather counterproductive in that case?
Yeah, actually, this communication is also important, as you said. For example, when we detect stress, we cannot say, okay, you look like stress, do you want to try this? I think it should be more seamless communication. For example, we just think about some chatbot and it interacts with you. For example, like a friend, and say, okay, for example, do you want to listen this music? You always like this. So this communication should not be, okay, you are stressed, but maybe how are you? Are you fine? Like this. So communication is also important in this one, and we can use this chatbots and LLMs. Actually, they are actually helpful in these cases, but actually it should be seamless as possible. We cannot actually say, okay, you are stressed, because it can increase the stress even further.
Thank you very much for your talk. I have two questions. The first one is, how did you define or did you categorize the stress levels for training your models?
Yeah, for example, for daily life, actually we rely only on self-reports for our models. So when we collected data, we ask people to actually evaluate their stress levels in some specific intervals, so that we can use them as ground truth and we can train our models. So we are using this self-reports for actually we trust users for their self-report.
Okay, thank you. And the second question was, what were your inclusion and exclusion criteria for your experiments?
Yeah, actually, we didn't target specific, people. So we try to use actually generalized people, but of course we are trying to exclude, people with some psychological diseases. So we are trying to use, maybe they can have some, stress issues, but not, a psychological case, because it can create difficult situations for us. We try to actually use, general public as possible by excluding, people with disorders.
Thanks for the questions and answer. Vielen Dank für die Fragen und Antworten. Und als nächstes gehen wir auf den Livestream, einen Vortrag von Nana Schläger. Sie wird über zurück auf die Beine, intelligente Textilien zur Unterstützung der Kniegenesung, dazu sprechen aus Krefeld.